All right, good everyone. Today we're going to be talking about graphing quadratic functions. As we talked about yesterday, one of the key things we're going to be focusing on this week is full-out graphing of these problems. Now, a lot of what we're going to be focusing on early on is just analyzing a graph, but there are going to be some things that we're going to want to look for, be able to understand going into the lesson so that we can basically take this into account, okay? Well, the first thing we want to look at is just understanding and just kind of a quick review of what we talked about yesterday of just going over what a quadratic function looks like. Okay, so we talked about yesterday how your x-intercepts, or all this factoring we've been doing, are the two values that are going to cross through the x-axis. Okay, those are our x-intercepts. Our y-intercept is where we're actually crossing at the y-axis, and our vertex is basically that little bump. It's the very lowest or highest part of the graph. Okay, well, the one last thing we do want to discuss is something called axis of symmetry. So this graph has symmetry. Basically, I could rotate it. I could rotate this at any point through that dotted line, and I could always have the same picture. Okay, if I were to flip that graph, it would look just like this. So see how there's no change. Okay. Well, we always want to be able to label this, and the thing you have to understand is that the axis of symmetry is also just going with the vertex. Okay. So we're going to be kind of starting on understanding how to actually solve this all out and really working through it. But I just want to kind of get you the understanding of how do we actually go from point A to point B? What are we actually looking for in a graph? Well, if you can find these four things, the vertex, the y-intercept, x-intercept, and axis of symmetry, you can basically graph out any function or at least get a decent sketch of it. Okay? So let's just go ahead and talk about how to do this. Okay? The next thing we have to discuss is the other thing we talked about yesterday. Is the equation. Quadratic equations are written as so. And the key thing you want to understand is that the numbers next to your x are just labeled as a, b, and c. Okay? So what we want to be able to do is try to figure out, okay, well, how do I actually use that to my advantage? Okay? Well, let's go ahead and study this first problem. Okay? Let's say we want to try to identify the vertex, the y-intercept, the x-intercepts, and the axis of symmetry. All right? So let's go ahead and start this off and understand what my three letters are. A, B, and C. A equals 1, B equals -4, C equals -5. Okay, and notice how I got those. I literally just went down the line of each of the numbers. Okay? From there, let's go ahead and work some of this stuff out. Let's go ahead and find the vertex first. Well, the vertex is -b over 2a. Well, b is -4, so a negative of a -4 all over 2a. 2 times 1. Okay? That's going to come out to give you an answer of the top's going to become +4 because negative, the bottom's going to be 2. It's going to be an answer of 2. Well, to find the vertex, I got to take that 2 and plug it back into my original equation because we want to think of this as a coordinate. Technically, your vertex is the coordinate 2, comma, question mark. We don't know what the y value is. So we're going to take that x value and plug it in. This is 2 squared minus 4 times 2 minus 5. And if we work that out, this becomes 4 minus 8 minus 5, or we get a vertex at -13 plus 4, -9. So now, based off that information, we know our vertex is at -9. Okay? The next question we're going to have is we're going to find the y-intercept. Okay? And for the y-intercept, all we have to do is take the last number of this problem. Well, do you notice how there's a -5 right here? Well, easy enough. That's actually our y-intercept. Last one we have to find is our x-intercepts. And this goes back to everything we've been talking about. This means we're just going to factor. So I'm going to draw my x. I would have -5 on top, -4 on bottom, This should be -5, +1, x minus 5, x plus 1. And then if you remember back to set them equal to 0, we'd have to set them both equal to 0 and solve. This would be x equals 5 and -1. Okay, so notice how I'm basically just solving out for three different things. The vertex is a little bit new because we had to use that equation back on the first page, the -b over 2a. But after that, it's all pretty straightforward, okay? The y-intercept's just your last number, and your x-intercept's all that factoring we've done. So now if I want to graph it out, I just have to take these coordinates and apply them. Let's go ahead and make this. Let's go ahead and draw a coordinate plane with a low bottom. First up, we have a vertex at 2, -9. So I'm going to go right 2, down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I don't have a full grid for it, but it'd be somewhere down here. So that's our vertex. We have a y-intercept at -5. 1, 2, 3, 4, 5. And we have two x-intercepts at 5 and -1. So -1 and 1, 2, 3, 4, 5. And if you notice, based off the dots, we can sketch a close enough graph to what it would look like. Okay? Now, the last question we got from this is this a maximum or a minimum? Key thing with this problem, it's really just to understand that we just want to go look at our vertex. And since it's at the bottom of our graph, since it's our lowest point, we can automatically assume that this is probably going to be a minimum. Questions on that? Okay. Make sure you take any questions over this problem. You bring them into class next day. We'll talk about it. Besides that, that's kind of the focus of the lesson. We'll be discussing this in class of like going from these problems, pulling out important piece of information, and then applying it to each of these problems, okay? Besides that, have a great day. Make sure you're finishing up the 8 puzzle questions, and I'll see you in class tomorrow or after Tuesday.